Hi, we're still in unit number 2, and we're on page 12 of unit number 2, working through g-forces. We just talked about acceleration, derived the big three, and also practice using the big three. Now we're going to talk about some applications of acceleration and some examples of it. One great example is so g-force. This is a multiple number of times your body's being accelerated relative. Right now, to know what is the acceleration of gravity. What is that number? Number is 9.8 meters per second. So it's right here, and you call, if you acceleration equal to 9 per second squared, we call that 1g, an acceleration. So when people talk about g, it is an acceleration. We know it's an acceleration because it's measured 9.8 meters per second squared right down here. Actually, the page. So that's acceleration right there. Acceleration, or 1g divided, or acceleration. So what are some typical common accelerations that maybe you've experienced? 9 meters per second squared means, or 1, which in 1g, remember 1g and 9.8 meters per second squared, the same thing. Airplane at takeoff, and really I probably should put at takeoff there. It's basically about 0.2 g, so that's not too bad. Those of you that have flown an airplane, if you want to know, roughly 1.2 g or 0.2 is, takes off from the tarmac right at the beginning, and accelerates, and you feel like you're being pushed in the back seat. That's what 0.2 G's are. Now notice that's not even one full G. Let's keep it up a little bit. If you've ever roller coaster, and at the bottom, climb up to the top of the hill, they let you go, and you scream down to the bottom of the roller coaster. You got a big, giant turn at the bottom. All right, at the bottom, it's going to be very quick, and you have that really turn. Remember, turning is accelerating. When that enormous turn at the bottom of the roller coaster, you're experiencing 2 to 3 G's. That's quite a few, but most people probably have a coaster. Maybe now don't like to roller coasters. Most people probably have at the bottom of those big turns, basically 2 to 3 G's, and that's quite a bit because you are aware of that because you probably have experienced that. All right, one that most people haven't probably experienced is the space shuttle, the space shuttle, and you've seen pictures of the faces of astronauts as they take off from the platform. Now, as a matter of fact, the space shuttle is now decommissioned, so it's kind of NASCAR, when they round the corners or the turns, 4 to 5 G's, so it's quite big. And the F-16s, 9 G's for some time. And we're going to talk about can the body in just a moment. We're going to talk about survive 9 G's, because 9 G's is a lot. That's a lot of acceleration, and what happens to your body curve. All right, so that brings us into this whole positives. And so we give you a definition, and then we'll talk through examples. So, circular acceleration that causes the blood of the human body towards the feet. And it looks like my video choppy here. I hope the audio is coming. A normal human being can withstand about to 5 positive G's before passing out due to blood and to the brain. So talk a little bit about why does the brain lose oxygen, lose blood during G-forces. All right, so let's take a quick example, and let's draw maybe a loop, maybe like not a good. All right, so there's my fighter plane, and there it is going around the turn. When it gets up here, the fighter plane's going to be upside down. Now I'm not going to draw the plane itself, but I am going to draw the seat and the pilot. So here's the pilot in there a little bit. It's a wonderful notice. Some arms here. Notice when the guy's at the top of the loop, or the woman is at the top of the loop, he's upside down, or she's upside down. So what happens to the body? Well, when you go through a loop like that, the blood of your body rushes to the outside edge of its container. Now, the container is going to be the human body. The blood literally forms or pools in the legs of the body, and it leaves, not totally, not all the blood leaves, but a good portion of it, or some, maybe I should say this, leaves the brain. And since the brain carries oxygen, then there's not as much oxygen in the brain, and that's what happens when pilots pass out. They pass out with lack of oxygen in the brain because most of the blood, or a lot of the blood, has been pushed or flows towards the leg. So how do they, how do pilots deal with this? Well, they deal with it in two different ways. One is they work on some breathing techniques, helps keep the blood near the top of their body, okay, the torso. They also wear G suits, and basically G suits is basically like a pair of pants. The step two, they plug that pair of pants into the console of the jet. When the G forces start to increase, then what happens is that pair of pants, the G suit, literally it's like a balloon. It inflates and it legs of the pilot. And as it presses against the legs of the pilot, it prevents the blood from flowing in the legs. If it does flow into the legs, then it's going to near the torso of the pilot and head of the pilot, and hopefully prevent the pilot. And so that's positive G forces. You may have heard of negative G forces. And let me zoom out a little bit so you can see what's going on here. Here's negative forces. Negative G forces. I'll give you the definition first. A scalar accelerated blood of the human body accelerated head. Now, for glance, you might think, well, hey, that's a positive, because last time positive G forces, the blood flowed in legs, left head, and that would be because it could cause pass. Well, there's another issue that could possibly occur with all the blood flowing to the head, and so a normal human being would stand to the negative G's before serious injury, due to long blank here. The blood vessels in the eyes. For serious blood in the eyes, and that's what we call it times a red out. Actually, happens is too much blood will be in the head, and it'll cause blood vessels in your eyes to pop, and so that gives your turns your eyes or the whites of your eye good. So we have to be with negative G's.